All right, guys, so before we move on to the three-wire, I just wanted to bring one more term out, being the RLO, the result of logic operation. And I also wanted to go over the normally open and normally closed instructions, just to make sure that we're totally cool with that before we move forwards, because they are basically what we're going to use 99% of the time in all of our PLC programs. So this one right here, the normally open contact, which we made use of in both the AND circuit and the OR circuit, it says that it returns an RLO, right, which is a result of logic operation of 1 if the value of the queried operand equals 1. So I tried to simplify that down to the normally open contact looks for a 1 in the memory. It also looks for voltage present at the input terminals, and it looks for something being on. So it looks for those three things, whether something's on, whether there's voltage present, or whether there is a 1 in the memory of the PLC. If any of those are true, then this instruction will be true, and then the output that corresponds to it will be true as well. Okay, this one right here for the normally closed contact, it returns an RLO, a result of logic operation of 1, if the value of the queried operand equals 0. So this one is looking for the presence of 0, or no voltage, or the fact that something's off. Okay, so the normally open looks for, again, a 1 in the memory, and the normally closed looks for a 0 in the memory. Okay, let's look at a number of different examples here and see if this will help you to make sense of us. Okay, so for this one right here, we have two normally open contacts here. Those guys are looking for the presence of 1. So if I have pressed this one, this push button right here, and this is giving me a 1 at the input, then the result of that logic operation will be a 1. For this one here, if I press the push button 2 at the same time, and it provides voltage to the input terminal and a 1 in the memory, it's looking for a 1, and so the result of logic operation for this guy will be a 1 as well. This is a 1, and this is a 1, so this is on. And when this output goes on, it is also represented by a 1. So I'll use these three terms kind of synonymously, being a 1 in the memory is showing that something's on or that something is true. Okay, let's take a look at some more examples here. Instead of doing an answer, let's just look at one contact at a time. So this is the push button that I have wired up to this input right here, input 0.0. So I have a physically normally open contact. Okay, so that push button is a normally open push button out in the field. It is wired, physically wired to percent input 0.0, so the first terminal for the inputs. Okay, and the example here is that the normally open push button has not been pressed. Okay, if I have not pressed this push button, then at this input terminal, there will be no voltage. So the signal from that normally open push button is going to be a 0 corresponding to no voltage at that input. Okay, this one is looking for the presence of a 1, but I have a 0 at the input there. So it doesn't correspond to what this is looking for. So the result of logic operation for this guy is going to be a 0. If this is a 0, for my result of logic operation, then this is going to be off. Okay, so again, this looks for the presence of a 1. If I haven't pressed that push button, I don't have a 1 in the memory, so the result of that logic operation is a 0, and because of that, this is not going to turn on. Okay, let's take a look at the next one. Okay, I'm going to use the same push button, but a different instruction. Okay, so for this one, I have, again, a physically normally open push button, but I'm making use of a normally closed PLC instruction here. I have physically wired this normally open push button to input 0.0. I have not pressed that push button. And if I haven't pressed that push button, then there's no voltage going into the PLC. If there's no voltage going into the PLC, that means that there's a 0 as a signal from that normally open push button. This is looking for a 0. I actually have a 0. So the result of that logic operation is that this is true. So if this is true, it goes green, and it's the only instruction I have before my assignment here, or my output. So if this is true, then this will be on. Okay, let's take a look at the next example. So for there, we've had a physically normally open push button, and we made use of the normally open and the normally closed PLC instruction. Okay, let's take a look at the next one. Okay, this is the same push button. So same push button as we just looked at over here. But now we're going to actually press that push button. Okay, I've gone back to the normally open PLC instruction here. This is looking for the presence of a 1 in the memory. If I press that push button, then I'll have voltage applied to the PLC. When I have voltage applied to the PLC, there will be a 1 in the memory. This is looking for the presence of 1. I actually have a 1 in the memory, so the result of logic operation for this would be a 1, or true. If this is true, it's the only instruction before my assignment, so now my assignment is true as well, so %q 0.0 will go true, or it will be on, or there'll be a 1 in the memory that corresponds to this output here. Okay, let's take a look at the same push button being pressed, but with a separate PLC instruction. Okay, so again, same normally open push button. We're actually pressing that push button, so that means that the signal is going into the PLC, which means that there will be a 1 registered in the memory for whatever this is wired up to. This is physically wired to %input 0.0, so that bit of information would have changed to a 1. But this instruction right here, the normally closed PLC instruction, is looking for the presence of a 0. I have a 1 as the signal from my push button. These two do not jive. This is looking for a 0, but I have a 1 in the memory. So the result of this logic here is going to be a 0, meaning that it's not true. If this is not true, and it's the only thing that turns on my assignment, then this being not true makes this untrue as well, or false, or 0 in the memory, or off. Okay, so we've covered each of the PLC instructions corresponding to a physically normally open push button. Let's take a look at a physically normally closed push button and each of the PLC instructions. And we'll see if we can come to an agreement on each of these guys. So we've switched over from a normally open to a physically normally closed contact. So there's a spring that keeps this guy in place. And if nobody touches that push button, it has continuity from this contact to this contact here. Okay? In this example, the physically normally closed push button has not been pressed. It's still in its rest state, meaning that the signal goes straight through that push button. If the signal goes straight through that push button, then I have voltage being applied to that input terminal. I've changed over now to %input 0.1, so I have that wired to input terminal number 1, and the signal coming from that normally closed push button is 24 volts, and there's a 1 registered in the memory. This instruction right here, the normally open PLC instruction, looks for the presence of a 1. I have a 1 coming in, it's looking for the presence of a 1 in the memory, and so this is true, meaning that the result of logic operation is a 1. So that result of logic operation being a 1 means that it's actually true. Once it's true, this goes green, and if it's the only thing that goes between there and my output, then my output goes green as well, so it goes true, changes from a 0 to a 1 in the memory, and turns on my output terminal number 1. Okay, let's take a look at the same push button, but using a normally closed PLC instruction. So in this example, we have a physically normally closed push button that is wired up to %input 0.1, so terminal number 1 on my input terminals. And we know that the signal is going straight through. That means that I have 24 volts being applied to that input terminal. And that means that there would be a 1 in the memory, which we're seeing right here. So the signal from that normally closed push button that has not been pressed is a 1. The problem is that this instruction right here in the PLC, the normally closed PLC instruction, looks for the presence of a 0. And these two things do not jive. This is the 1 in the memory, It's looking for a 0 in the memory. These are not the same. So the result of that logic operation is a 0, or it's false. So that means that if that's the only thing that would turn on our output over here, that our output is also false, or it still remains as a 0 in the memory, or it's off. Okay, let's take a look at the next one. We're looking at the same normally closed push button, but this is when we actually press that button. So we change the state of the normally closed push button. So we've actually pressed it, which means that there's no way that that signal can get into the PLC. So the PLC is registering 0 volts at that input terminal. This instruction right here, the normally open PLC instruction, looks for the presence of a 1, or looks for voltage being present. There is no voltage present here. In the memory, the signal is a 0, and so these two do not jive. This is looking for a 1. The signal that's coming in is a 0. So the result of logic operation for this is a 0. It's false. And if that's the only thing between here and the output, if this is false as well, meaning that it remains as a 0 in the memory or remains in the off state. Okay, let's take a look at the next one here, guys. So this is the same normally closed push button. It has been pressed, and so we're stopping that signal from going into the PLC. So there is a 0 in the memory for that input terminal, input 0.1, because there's no voltage there. No voltage is represented by a 0. This instruction, the normally closed PLC instruction, looks for the presence of a 0. I have 0 in the memory corresponding to that input. I'm looking for a 0. Those two match, and so the result of logic operation for this is a 1, meaning that this is true. And if this is the only thing between here and the output, if this guy is true, then the output's true, meaning that the output just turned on, and the bit of information that corresponds to that output terminal, Q0.1, just went from a 0 to a 1. Okay, so the result of logic operation is primarily saying, is it true or is it false? In this case, I'm looking for a 0. I have a 0 in the memory. If those two match, I get a result of logic operation of a 1. This is true, so this is true. If we looked at the previous example here, I don't have a signal coming in here. I have a 0 in the memory. This instruction is looking for a 1 in the memory. These two are not the same in that the signal does not match what this is looking for. So the result of logic operation is a 0. It's false. And if this is false, then the output that's tied to it is false as well. So the takeaway from this is that we've basically discovered that a physically normally open or physically normally closed push button can be expressed with either a normally open or a normally closed contact. It really depends on what logic you're looking for. Are you looking for voltage being impressed at the terminal or no voltage being impressed at the terminal? Are you looking for a 1 in the memory or are you looking for a 0 in the memory? So it's no longer the path of current that decides your logic. It's that every single push button or sensor is wired to a separate terminal on the PLC input there. And within our PLC program, we can then change the instruction to change the logic of that push button there. So what's frustrating is that there is no hard and fast rule that a physically normally open push button means that you use a normally open instruction. And that also means that a normally closed push button does not mean that you need a normally closed PLC instruction. You can use either one of the PLC instructions. It's really a matter of what logic you're looking for from that push button. You're looking to see whether it's false or whether it's true. And that's probably the hardest thing to get your head around. Once we've done a number of different more examples, then it will become a little bit more apparent. And then the confusion that you're having right now will be totally gone. Everything will make sense, but it does take a little bit of time for this to kind of percolate through. We look at a couple more examples and you're like, oh, that's what he was talking about. Now I'm understanding this logic thing that he's talking about. Now I understand that it doesn't matter that I have the wrong push button in the truck, right? Like I'm looking for a normally open, but I only have a normally closed contact. That's going into my PLC. It doesn't matter how it's wired. I can use the opposite PLC instruction to make that work within my program. All right, hopefully everything clears up on the next example, guys. Let's take a look at the 3-wire control.